Hello everybody. So the aim of this session is to show you how Rubrik works and how Rubrik can be integrated with the OpenIO solution and mainly the archival processing on the object storage that we can leverage natively. Let's start with a small presentation of Rubrik. So the aim of Rubrik is to gather the data and to leverage the different backup module and the different way we can back up the data to manage it then through your private cloud or your public cloud. So let's start with a small back in the future travel. So 19 to present. I think that everybody can see and can recognize a traditional infrastructure about backup. So the main purpose of this slide is to show you that each of these functionality is nothing than each silo. One GUI, one thing to manage, one thing to grow, to scale. And one small evolution is beginning of 2000, the dedupe metadata and the backup on the storage on this that appears and that allow the different customer to move to those different technologies. So quick explanation of how we can work with that. Rubrik is taking all those functionality of those silos and is merging everything in an appliance that is driven by our software that can scale infinitely through our web scale and scale out way of thinking, which are mainly our distributed file system and the way that we can integrate with the public and the private cloud. So 6 steps, how we work. This is a quick start installation. So this means that in less than 45 minutes, your cluster is up and running and you can start to back up your data. Then we are thinking and we are breaking the job and the different job that you have to orchestrate and launch automatically. We are thinking with the SLA way, like you can do with a DR. So associate a frequency of backup and then a retention to this. Then we are using some process that can allow us to ingest very quickly the data with our SSDs that are present inside each of our appliances, and then we are putting the data that we can compress, dedupe, and index into one single namespace, one single repository. Then we are using our SSDs to accelerate the different recovery phases, so which mean live mount. We can, like I demonstrate a few minutes ago in the other room, so we can put back a VM in production in less than a minute, whatever its size, 10 gigs, 100 gigs, 10 terabyte. This is not a problem for us. We can do an instant search and instant file restore, which are allowed by our different metadata and indexes that we are creating and maintaining. Security is really important today, so we are encrypting the data from end to end by design, and then we can encrypt the data on our different file system, and we are actually immutable to the different ransomware because of the way our software is done. We leverage a Linux kernel that we have enforced and then we have compiled again. And then we are using the cloud, public or private cloud, to leverage the different functionalities. First, cloud out, which allow you to archive the data and then maintain a small and a single file restore. We will leverage OpenIO, for example, with the different object storage that you can have on-prem. And the cloud on that will allow you to instantiate an on-prem VM to a cloud, a public cloud, that can be GCP, Azure, or AWS today.
Thank you. Okay. So, as explained by Gatien, we provide object storage solution to preserve your data for long-term retention or for archiving. So with our architecture, we are able to provide a scalable platform where we can start with a few nodes and evaluate to hundreds of nodes with the same architecture in a simple way, as explained this morning by Enrico. So we can manage a lot of data in petabyte or hundreds of terabytes if you need less of capacity. But we can manage a lot of objects of images, backup images. We can start with a few images and can scale up to 10 of billion of objects if you need it. And everything is managed with the brain of the solution called the conscience and give you the best way to use your hardware. So we are open source, we are totally agnostic, so we can support any type of hardware with our solution, and we can provide different type of architecture with different type of provider of server with different hardware provider. We can provide a lower TCO with our architecture, and we can scale with what you need in terms of capacity or in terms of object to manage. To provide access to your data and to some application like Rubrik, we support a standard, open standard API for object storage like S3 and Swift, give you a way to retrieve your data with a standard protocol. And we can provide parallelism and performance with multiple gateway if you need performance. Even in this case, we are more a second tier for the backup and for the archiving. Pardon, je me suis trompé. So, what is the benefits of our solution? We provide a grid of nodes, a grid of storage with servers and disk, and we can scale this platform, adding nodes when you need the capacity or when you need to manage more images or archiving. And this scale is done without interruption, without a blackout window to do this. We are using the conscience. The conscience is the brain of our session. We don't need to rebalance the data when you scale your architecture, and the conscience will show the best components, the best node of the platform when you have to serve the data. You are open source. Open source take you the control of your architecture, of your solution, and provide you a way to be not border locking with our solution, and give you a way if you want to change the solution between OpenIO to another private cloud provider, we can swap the solution. Last, we can provide you multiple protection scheme to protect your data with Azure coding, with GeoCluster, with replication, and we can support different type of architecture if you need to have your architecture stretch across different data center and provide access to your data by the Rubrik nodes to a different data center.
So, how do we change your backup and your infrastructure today? This is quite simple. I think that everybody can recognize the traditional infrastructure. So what can interest us here is the main backup part. The first principle is quite easy. We are taking this, we are moving to that. So just using one single appliance, and then you can rule and use the different storage that can be provided to you. So in a private cloud example, some OpenIO infrastructure with your storage object infrastructure, or in the public cloud, the different main cloud provider that can be showed here. So main thing is that we can use those storage to do some long-term retention that can be also known as archival for different actors, and we can continue to do the same search and restore thing with the different in a granular way. So we can still continue to back up and restore a single file or a single folder, single VM, etc. Then we can apply the same thing and the same principle to a DR. So use a stretch cursor of OpenIO to gather the information into multiple sites. And in case of a loss of services or loss of different functionality in your main production site, you can move to your DR with less architecture, less hardware, less software, but use your different cluster of object storage of OpenIO to read, link the metadata, and restore the different information in less than a minute too, because we are only reading the metadata to know what is the data that is present on the different cluster. Small benefits. I think that we can at least, we should at least put the two logos, because we have quite the same. So it's easy to deploy. There is no babysitting things on the different day after day. This is quite simple. This is really simple to use it. Simple to scale. As our concern, we are only growing by 2U increment. Each increment of 2U are using 4 different servers. You can grow servers by servers and then add storage and add performance. And then we have a lower TCO, a lower total cost of ownership than our different competitor, because of the way we are thinking the different licensing and the different things that we can provide to our customer.
So, with OpenIO, we provide for long-term retention and archiving. We provide a scalable architecture. We don't need to rebalance the data when you have to scale your architecture and scale for capacity and performance. We are open source. You are using Open Standard API for you. It's the best way to use our solution and to migrate if you need from a cloud, from private cloud to public cloud, or from public cloud to public cloud. We provide a parallel architecture. This parallel architecture provides performance, provide availability. We support GeoCluster configuration when you have a multi-data center, and we are able to provide availability to your Rubrik architecture. We have no SPOF, because every services, every data is split on different nodes on our architecture, and we provide great availability for your data. We provide resiliency with the protection mechanisms like eraser coding or multiple copy of the object. And last thing, when you preserve your data on long-term retention, it's always hard to know if your data are still the good data, not corrupt by anything. So you have we provide a safe-healing process to manage long-term retention, to be sure your data is still the good data with no corruption of your data stored on on our solution.
So we are talking a lot about cloud. This is a huge thing today, and this is something that is going back a lot in our different presentation. But the aim is to work actually with the different cloud. So you can work on-premise, but you can work with the different cloud, with Amazon AWS or with Microsoft Azure, and deploy what we are calling some cloud cluster that will allow you to protect your different instances in the cloud. And the same way as we are working with the different on-prem infrastructure, which means doing some archival, doing some replication, the idea was to say, hey, we can say this, we can do this with the on-prem, but what if we can do this with the different cloud provider today? What if I'm able to back up my EC2 instances in AWS, then replicate everything, all the data, to my on-prem storage or to my Azure storage, just to securize everything, just in case that if my region, if my VPC is broken or is falling down, I can replicate and I can restore it again in another instance, in another region. So this is the way we are thinking, and this is how we can be implemented with the same logic in an on-prem situation, in an on-prem instances with OpenIO as an object storage for the different replication, archival, etc. things. Thank you. And we have an open Q&A for you, so feel free to ask any question or anything. There are absolutely no silly questions, so feel free to ask.